Hello students, we are back, right? So now looking at the third part on the lessons on polygons. So poly means many, right? Gons means side, so many sides. So now we are looking beyond three-sided and four-sided shapes, which we are quite comfortable with. And what happens when there are more sides? What kind of information do we know, right? So let's begin. So of course, do read your textbook beforehand so that you have some idea what we are dealing with here. So let's look at these polygons, right? So there are nine-sided polygons and 10-sided polygons over here. They do have names, right? So the nine-sided polygons is actually called the nanogon, and the 10-sided polygons is called the decagon, right? So do you know the names of all the other sided polygons, like 5-sided, 6-sided, 7-sided, 8-sided, for example? Well, let's pause the video and we can discuss that. And we're back, right? So here's the trick, right? So what we are dealing with is now we have these polygons, but something interesting happened, right? Because what we can do when we look at a polygon like this, we realize that we can actually break it up into little triangles, right? So every polygon, we can break it up into little triangles, right? Doesn't matter how you do it, but right, so they're all there, okay? And same thing here, we can break out into little triangles, and you can count, right? You can count the number of triangles you can actually form, okay? And what's interesting is there's a pattern to it, right? So the number of triangles formed in this case is actually 7, and the number of triangles you can form in this case is actually 8. And we can try for other number of sided triangle, whether it's 4-sided, 5-sided, 6-sided. You try it out. You should notice that the number of triangles we can form inside the polygon is actually 2 less than the number of sides. Okay, so what this tells us, right? Okay, let me see. There's a typo here. So there should be 10-sided over here, right? So what we should actually see is that the sum of interior angles, right, is actually 180 times the number of triangles that we can form inside the polygon. Okay, so when we do that, right, the sum of interior triangle over here is going to be 7 times 180 degrees, which will give us, let's pull out my calculator, clear, 180 times 7, that will give us 1260 degrees over here. Now, what happens if I got 8 triangles for the decagon? It will be, right, 8 times 180 degrees. That will give us 1440 degrees. So that's huge, right? And we can continue doing that for all the other number of sides, and eventually you should see a pattern. If you want to have to reinforce, okay, there's SLS lessons which I can point to you if you need to. Okay, so what happened, right? So what are some of the properties of the polygon we have discovered? Okay, so first of all, right, the polygon, okay, is basically formed by 3 or more straight edges, right? So this is what a polygon really is. We have, of course, 3 edges will give us a triangle, and then we have 4, 5, 6, and so on. So that's what a proper polygon is, right? Next, it is a closed figure, right? Because it's a closed figure, right? All the vertices, they join together, and it is a plane figure. Plane figure means it's 2-dimensional, right? So these are some of the things that defines what a polygon is. Okay, so what other things we know about polygon now that we identify the properties? Well, the interior angles, right? The interior angles, the sum of the interior angles, is going to be equals to the number of triangles we can form inside times 180 degrees. So for a polygon with n number of sides, we use the letter n quite often here. The number of triangles will be n minus 2. And when we multiply by 180 degrees, that should give us the total interior angles. And how about the exterior angles, right? Remember we talked about exterior angles when we were discussing about triangles. The sum of the exterior angles, now regardless of the number of sides, will actually be equals to 360 degrees. Okay, why is that so? We will figure it out later on in the chapter. Okay, so these are some of the key points that you can actually derive after going through the lesson in SLS. I just sum it up for you here. So when you go home, do assess the SLS and see what you can learn, right? So here, okay, is where we want to really look at the relationship once again. Because I hope you see the pattern, right? So here we have, let's say we have a 5-sided figure, right? So a 5-sided figure is also called a pentagon. So if you have a 5-sided figure, it looks something like this, right? And naturally, if they will have also 5 pairs of interior and exterior angles. Okay, so there will be 5 pairs, right? 5 pairs. And a 6-sided side will 6, and n-sided will have n, right? So let's see the pattern, right? So the sum of the interior and exterior angles naturally will be 5 times 180, because we know that the interior and exterior angles add up to 180, right? So 5 times 180 will give us 900 degrees over here. Okay? Now if it's a 6-sided, which is a hexagon, we get 1080, right? And of course, if n-sided, it will just be 180 n. Got it? Okay. How about the interior angles? Well, interior angles, we already know that it's going to be the number of triangles times 180. So for 5-sided shape, we can form 3 triangles. So 3 times 180 give us 540, right? And then over here it will be 6-sided means that we can form 3 triangles. So that gives us 4 triangles. So 4 times 180 give us 720 degrees. So what happened is, if we want to find, let me change the color of my pen over here, zoom in here. We want to find the sum of the exterior angles, which is all the blue parts over here. It will simply be all these angles 5 times of the 180 minus away the total interior angles, which I will mark out in, I'll mark it in green, right? So you see how it works? So if I take the 5 times 180 degrees, which is the sum of the interior and exterior angles together, minus away the interior angles, I actually get the exterior angles. So from here, we can see that 900 minus 540 is actually 360. So, and similarly, right? So regardless of the number of sides of the polygon, you find that it always end up with the sum of exterior angles as 360, right? So over here, right, if it's in terms of n, okay, we also know that it's going to be 180 times n minus 2, which is the number of triangles we can form. So when we subtract it, right, we have 180 minus 180 n minus 2, we end up with 180 n minus 180 n plus 360, which will result again into 360 degrees. So it always works. Okay. Okay. So now on your handout, there's also a little link to a GeoGebra page where we can actually confirm all these properties of a polygon. I'm going to give you some time. You can go in and explore, and then in your own words, tell me what you learned after exploring the GeoGebra. Okay, so you can pause the video here. And we are back, right? So I hope you had some fun exploring the GeoGebra and our discussion in person. So let's sum up the entire lesson on what we have learned on the theory section of polygon. So an n-gon, right, will have n number of sides, right? And it will have n interior angles and n exterior angles. Now we know that for each pair of interior and exterior angles, they add up to 180 degrees, right? Therefore, the sum of the interior angles, okay, we also know that this is actually n minus 2, which gives us the number of triangles we can form times 180 degrees. Okay, some of you may be more comfortable writing it in this manner, 180 and minus 2 degrees, right? So we can do that. Okay, so the sum of each interior angles of a regular polygon, right? Regular means all the lengths and the angles inside are the same size. So this will be 180 n minus 2 divided by n. Okay, now for the exterior angles, we also figure it out that it's going to be 360. Therefore, sum of each exterior angles of a regular polygon will be 360 degrees divided by n. Right? So do take note that this only works for regular polygon, right? And that is the theory section. So now let's move on to some examples. Okay. So here we have three of the interior angles of an n-sided polygons. Okay, they tell us that three of them is this. The number of sides we do not know yet, but the remaining interior angles are 146 degrees each. So they want us to find the value of n, right? So how do we actually go about that, right? So we know, okay, a few things. We know that the sum of exterior angles, right, is going to be in this manner. Let's write now. Sum of interior angles, right, is going to be 76 degrees plus 169 degrees plus 105 degrees plus, and then we have 146 degrees. How many of them? Well, n minus 3, because we have taken out 3 already, right? So that is the amount. Okay, we simplify this, we should end up with 146n minus 88. So that is the sum of the interior angles, right? So what happened next? Okay, we also know that this value 146n minus 88 is going to be equals to the number of triangles we can form, which is n minus 2 times 180. So maybe let's write it in the other format for easier algebra expression, n minus 2. Okay, so that gives us 146n minus 88 equals to 180n minus 360. That will give us 180n minus 146n equals to 360 minus 88. So 34n is equals to 272, n is equals to 8. So this is an eight-sided polygon, also known as an octagon, right? Got it? I hope this makes sense to you. If you need some time to review it again, do so. If you have difficulty, please, okay, make an appointment and let's speak in person. Right, so here's another example. That this time around, instead of interior angles, they give us exterior angles. So do take note, you're doing exterior angles now. So how does it go? It tells us that there's an n-sided polygon. Two of the interior angles, right? So please read carefully. It's 127 and 135. And the remaining interior angles is 173. So we are going to actually work it out the same way, right? So what happened is we know the exterior angles is 50. So interior angles, right? The interior angles of the given okay, interior angles of given angles is actually 180 minus 50 degrees, which is 130 degrees. So we are dealing with the first three, right? So three of the interior angles is actually 130 because three of the exterior angles is 50. So that is the first thing that we need to we figure out, right? So from here, now we can add up all the interior angles, right? So sum of interior angles is equals to 3 of them is 130 degrees, right? 3 of them is 130 degrees. And then 1 of them is 127 degrees. 1 of them is 135 degrees. And the remainder, which we do not know how many, right, is 173 degrees. But how many? Well, it's the total n minus 5 because we are account for 5, right? 3 of them already taken out, and then 3, 4, 5 here, right? So 5 already accounted for. So we simplify this. This will give us 3 times, use your calculator, you should get 173n minus 213 degrees. So this is a sum, right? Again, now we match it with the formula. 180 n minus 2 is going to be equal to 173 n minus 213. So 180 n minus 360 is 173 n minus 213. So 180 minus 173, we have 7n equals to 147, right? Therefore, n is equals to 21. So it's a 21-sided polygon. Huge, right? But it works, okay? So the mathematics will work, right? So, yep, you may need some time to digest this. That's why I'm providing you a video of this so that you can watch it again and again until you make sense out of it, right? But if you see a difficulty, of course, please look for somebody to ask, like me, right? Okay, so in the figure, here's another example, right? In the figure, we have a regular pentagon on one side, A, B, C, D, E, and we have a hexagon on the other side, right? So they want us to find a lot of these angles here, right? So ABP. So let's mark it out. ABP is over here, right? So ABP is just one of the interior angles of the hexagon. Therefore, right, we can do it quite easily, right? Angle ABP, okay, is the interior angle of hexagon. Interior angle of hexagon, we know that it's going to be 6 minus 2 times 180 degrees divided by 6, okay, which will give us 120 degrees. Okay, so we got that, the first one. Okay, this is the interior angle, right, of a hexagon. The next one, they want us to look for PQX. So let's do it. PQX is this angle over here. Now this angle over here is half of the interior angle, right? Therefore, okay, you can see that PQR is actually the interior angle, so half of it, right? So we already know that the interior angle is 120, therefore angle PQX is going to be 120 over 2, which is 60 degrees. All good? Okay, next one. Next one, they want us to look for AXB. So AXB is this angle over here. Now this angle over here is interesting because for a regular hexagon, right, triangle, this triangle that I'm going to draw in red, this is actually an equilateral triangle. Okay, this is actually an equilateral triangle, right? So from here we can declare that angle XB is equals to 60 degrees, and let people know how we do it, right? We didn't pull it out from the air because triangle AXB is an equilateral triangle. Okay, so we got that. Part 4, let's see, what do they want? Part 4, we are looking for triangle ABC. Well, ABC is over here. So this is an interior angle of the regular pentagon. So we can do that, right? Angle ABC is going to be 5 minus 2 times 180 degrees over 5. Excuse me. And that works out to be 108 degrees. Excuse me. So next one, we want angle ACD. ACD, okay, we need to draw it out a little bit. So maybe I change the color of my pen. Right, ACD is this angle over here. So this one a little bit more challenging. It takes a few more steps. Okay, what happened is first we need to figure out what is this angle over here in green, right? Because this is an isosceles triangle. So if we know the green angle and then we just take the interior angle of a pentagon, subtract the green one, we got it, right? So this one a bit more steps. Okay, so let's begin. We have part 5. We find angle BCA first, right? Angle BCA is 180 degrees. minus away 108, which is ABC, divided by 2, right? The reason this is actually the base angles of isosceles triangle. So that works out to be 36 degrees, right? Therefore, angle ACD, let's write that properly. ACD is going to be 108 degrees minus away 36 degrees, which gives us 72 degrees. Okay? And finally, they want us to find the angle ASE. So that's interesting. Let's draw it out, maybe change the color purple. ASE is this angle over here, right? So how do we get that? Well, this one will take a little bit more effort. What we need to do is we need to find angle SAE first, right? So let's zoom in. What happens is if we can find angle ASE, which I also mark out on purple here, okay, we get this angle, then again, this is actually a isosceles triangle, okay? So how do we get that? Well, we can use angle at a point, right? So let's do part 6. Angle ASE, SAE first, right? Angle SAE, right? If we take all the angles around point A, let's look at the diagram, they include, right? So I take 360 degrees, they include the 120 degrees, okay? 120 degrees from the interior angles of the hexagon, minus away 108 degrees from the interior angle of the pentagon, right? So we do this one, the reason is angles at a point, right? So this works out to be 132 degrees. So finally, from here, we can find angle ASE by taking 180 minus 132 over 2. And the reason, it keep jumping, my screen. Again, this is base angles of isosceles triangle, right? So this works out to be 24 degrees. Cool, right? This type of questions. I hope you enjoyed that. Do we have more examples? Yes, we do, right? So here's another example where we can actually have some fun with. So we have a part of a polygon shown. The number of sides we do not know. They tell us that each exterior angle is 36. And they want us to find the value n. How many sides are there, right? So what we can do over here, well, what we can use exterior angle, right? Since they tell us that the exterior angle is 36. So from here, part 1, right? And we know that it's regular. So if it's regular, then what it means is that 36 degrees n number of times is actually equals to 360 degrees, which tells us that this is actually a 10-sided shape, right? So we got that. Then they want us to find the angle BDE. So maybe I mark it out. BDE is over here, right? So that's cool. Okay. So how do we actually go about finding this? Well, what we can do is we can find the interior angles first, right? So the interior angles will be useful because, let me change the color of my pen, because this is an interior angle over here, right? And then this is a isosceles triangle. So that will allow us to find this angle in red, and that will allow us to find the angle in purple, which is what we want. Okay, so quite a few steps involved. This is actually one of the more challenging questions, of course, but I believe in your ability to understand how all this works, right? So don't worry, let's do it step by step. So let's begin. So let's figure out first of all the size of each interior angles, right? So this will be 180 degrees minus away the exterior angles, which gives us 144 degrees. So we have that the size of each interior angles, and from there now we can find angle BCD, right? So angle BCD is equals to 144 degrees. Okay, we got that. So from here we can find CDX or CDB, right? So I'll just write down BDC, why not? Okay, so angle BDC will be 180 minus 144 over 2, and the reason is because they are base angles. Okay, let's write it properly. Base angle of isosceles triangle, right? So that works out to be 18 degrees. Therefore, right, therefore, angle BDE will be one interior angle minus away 18 degrees. Okay, let me write the degree properly so that it doesn't look like 180, right? And that will be 126 degrees. So that's the angle BDE. So finally, they want us to find angle CXD. So let's take a look at where they are. Maybe change the color of my pen so that it looks clearer on your screen. CXD is, this tiny little bit over here, right? Now, what happened is actually, if we zoom in, this is also an isosceles triangle, right? So since we already know one of the base angle of the isosceles triangle, this is not too complicated, right? Angle CXD is actually 180 degrees minus away 18 degrees twice, right? Which gives us 144 degrees, okay? And the reason, this is angle sum of triangle, right? We know that it is a isosceles triangle, so it works out quite well. All right, so with this, that ends the examples. Okay, so again, assignment 3, you can try these questions. Again, they are from review exercise 11, so you can append them all together as a single consolidated assignment. Okay, and the last portion here on symmetry, we will speak of them later, right?